Hello everyone. Today we are going to discuss about thermal power plant.
Now let us see what is thermal power. This thermal power is nothing but it is an energy that is generated by converting heat into electricity. That is electrical energy. It is converting heat energy into electrical energy. So in this process, electric power generation, steam operated turbines convert heat into mechanical power. Firstly, this using these turbines it is converted heat into mechanical power, and then finally it is converted to electric power. Directly it is not converted to this electric power. After this conversion of electric power, this electric power is stored in some powerhouse. By using that powerhouse, slowly this electrical energy is used. So now let us see how does thermal power plant work. First of all, let us take this fuel, fuel as an input. So that fuel, that is coal. By taking this coal as an input, we have took this example. So by crushing it, it produces some heat. So this heat crushed coal produces heat. So this heat is used in the boiler. In this boiler, it converts water into steam. So in this boiler, water is required. So this water is converted into steam. So this steam is sent to the turbine, that is steam turbine. So in this turbine, there are some blades. These blades start rotating because this steam having some high temperature and high pressure, so it start rotating. After this turbine is connected to the shaft of the generator. This shaft of the generator, which is connected to the steam turbine, also start rotating. After this, it slowly starts producing some electrical energy. This electrical energy is stored in the powerhouse. So there is finally, after this completion, there is another one thing is that for steam there is an system that converts steam back to the water. Because this steam, while evaporating, it converts to water. So this water is again sent to the boiler for converting into steam. Now let us see the working components of thermal power plant. First one is fuel storage and handling point. This is the most restrictive part in this thermal power plant because it is to store the fuel in adequate amount. That is, this thermal power plant can run smoothly if there is an any shortage of this fuel. The see fuel shortage facility is defined in a plant to store an adequate amount of fuel. So the first step in the process of fuel generation is, first the fuel is brought to the beaker source with the help of the belt conveyor. So by using the belt conveyor, the fuel is brought to the beaker source. So the fuel transport to the plant is generally bigger in size, the bigger in particle size, and uh, this before it is moved to the boiler funnel, it should be crushed. So this is crushed using these crushers. And now the next one is water treatment plant. So here we need large quantity of water. So by using the crushers, we crush the fuel and the heat is generated. Using the heat, we convert this water into steam in this boiler. So here it produces some high pressure and high temperature in this steam. So this steam and water will be direct contact with the blades of the turbine. With the direct contact, it start rotating. The blades start rotating in this turbine. So here, if there is no proper treatment, the efficiency and lifespan will be reduced in this system. Now, suspended matter from the water is removed by adding alum into the tank through gravity separation. After gravity separation, water softening is done by ion exchange process. And now the next one is steam boiler. A steam boiler is a pressure vessel which is used to generate high pressure steam at saturated temperature. The crushed fuel from the crushes is fed into the boiler furnace, generating a large amount of combustion heat. On the other hand, we will be having the treated water, uh, which is uh, which is sent it to the boiler. That water is free from impurities and air is fed into the boiler drum. So here in this boiler drum, it uh, takes the combustion of heat by which is produced by the fuel, and it starts boiling the water and start giving a steam. This steam will be having high temperature and high pressure. So this boiler's role is to convert water into steam. And now next one is turbine. It is a mechanical device which converts kinetic and pressure of steam into useful work. So whatever the steam we get, it converts the kinetic and pressure energy of steam into useful work. So this steam comes to the turbine, and the turbine's blade will be rotating, and this blade will be connected to the generator shaft of the generator. uh, so the shaft then rotates generator, which converts kinetic energy into electric energy. So as these turbines blades are rotating, automatically this generator's shaft also start rotating. While rotating this uh, shaft, shaft starts changing kinetic energy into electrical energy. So this finally this electrical energy is stored in powerhouse, and finally it is used. And now let us see the working procedure of thermal power plant. So here this is the boiler, and this is the generator, and these are the turbine. This is high pressure turbine, intermediate pressure turbine, low pressure turbine. This is powerhouse. The generated power will be stored here. So as we start as input, here we give the fuel as an input. So using the crusher, this fuel will be crushed and the heat will be produced. Here in the boiler, heat will be produced, and heat this heat starts boiling the water. So water will be given. So it start the boiling of water. This boiling of water, it produces as steam. It comes as a steam, and this steam comes to the turbine. Here the turbine will be here high pressure turbine, intermediate pressure turbine, and low pressure turbine. Here in this turbine, as it takes the steam from the boiler to the steam turbine, here uh, the steam is having some high temperature pressure with kinetic energy. It start rotating of the blades of the turbine. Here the blades will be rotating. So this blade is connected with the shaft of this generator. Here these blades will be rotating and automatically the shaft of the generator starts rotating. As this shaft of the generator be rotating, the kinetic energy will be converted to the electrical energy. This electrical energy is stored in the form of powerhouse here. So here one more thing is, as this steam will be again cooled down and it becomes water, so this water will be stored, and this steam is converted into water here, and this water again it gives supply for this boiler again. So here the for supplying the more water it is required. So finally if we come for the case of here generator, as this electricity is produced, it is stored in the form of powerhouse. It is stored in the powerhouse. So this powerhouse will be supplying the electrical energy for the necessary uses. Now let us see the pros and cons of this thermal power plant. First of all, the cost of the power generation is cost effective, that is affordable cost. And the next one is the fuel is abundant and economical. Next, the plant can be set up irrespective of any specific geographical requirement. So, compared to other power plant, it is easily planted and set up, and requires less area as compared to other power plants. So, comparing to other power plants, it does not require more area, it requires less area, and for a nuclear power plant it requires more area, like that. So if we come for the cons, the use of fossil fuels can cause depletion of resources. So using these fossil fuels, there will be crushing and burning, so this produces smoke, and it causes depletion of such as ozone, because it is the smoke, right? And requirement of huge quantity of water, we require more quantity of water for this plant. Overall low efficiency and lifespan, here the efficiency and lifespan will be less as compared to other. And high maintenance cost, there is more costly to maintain this power plant. So here in prawns it is the cost is for making buying the products, the cost is less, but for maintaining this thermal power plant, the for maintaining this it is more cost. Thank you.